Okay, this is Module 4, Lesson 13. We are talking about the graphs of linear equations in two variables. So starting on page 171, says that Maya predicts that the graph of x plus y equals 6 looks like the graph below. Do you agree? Explain. So take a minute, look at this graph. What do you think? Do you think this graph matches with the equation? Well, let's test a few points. So if I just pick out this point, that is the point 2, 4. So into the equation, instead of writing x, I'll write 2. Instead of writing y, I will write 4. Does 2 plus 4 equal 6? Yeah, it does. Let's try another point. This is the point, 4, 2, just the opposite. So obviously 4 plus 2 also equals 6. And let's try one more. This point is over 0, up 6. So x is 0 plus y is 6. Does that equal 6? Yes, it does. So looks like all of these points match up. So what is wrong with this graph? We don't see a graph of an equation that looks all snaky like that, right? What this person should have done is they should have actually drawn a straight line right through those points rather than this wavy line. Okay, so when we have points on a graph, of course, if I had point here and here, I'm not going to do something like this to get there. I'm going to actually draw a straight line that's going to connect those 2 points. On page 172, we're being asked to graph this equation. We already have several points here. We have the same equation, x plus y equals 6. But now we want to try some different points, some points that are not on the graph already. So you're just going to choose any point for x. So let's see, some things that are not on the graph. Maybe I'm going to choose 9. When x is 9, what is y? Well, I'm going to replace the 9 in my equation and then solve for y. So I'm going to just do that down here. 9 plus y equals 6. I want to get y alone, so I'm going to subtract 9 from both sides. I'm left with y equals 6 minus 9 is negative 3. So now I can actually add that point into my graph. So my point is 9, 3. So over 9, down 3, and I can add that point right onto the graph. So try a few others. You can even try negative numbers, right? Maybe I want to try negative 7. When x is negative 7, what is y? I'll do this one as an example. So negative 7 plus y equals 6. Again, I want to get y alone, so I'm going to add 7, y equals 13. So I don't have 13 on my graph, so this might not have been a great one, right? It's going to be all the way up here, the point 713. So it's okay to have it in your table, but you might not actually be able to graph it very accurately. So try some negative numbers, try some positive numbers. You can even try some decimal numbers, right? What if I had chosen the point, right, 2.5? Where would that be? Right, so you can try also some decimals. And definitely finish out this table you should be getting a bunch of values here, a bunch of points that can be plotted. Number 3 is very similar, just obviously also with now a different equation. Pointing out that you need at least 2 points in order to make a graph. Don't draw this, but if I just had 1 point here, well, I don't know where my line is. Is this my line? Is this my line, right? What is the line that represents this graph? I need to have at least 2 points to be able to tell, like, oh, where my line might actually be going. Okay, so make sure you have 2 points here. You can choose any point for x, right? You're choosing any number here. That's not a 0. That's like, you're choosing any number, right, to go here, any number. And then plugging that number into the equation so that you can then get your y. You're also doing the same thing on page 174, the difference here being that you now have a fraction. So I'm going to do one of these with you. That's why I drew this extra spot, because I want you to come up with 2 points on your own. We are going to do the first one together. So my equation is 1/3 x minus y equals 2. I'm going to choose something that I know is divisible by 3, so I'm going to choose 9. Again, I could have chosen a positive 9, I could have chosen a negative 9, doesn't matter, but I'm just choosing a positive 9 to show you the math on this and just refresh your memory here. So I have 1/3 times x, but instead of writing x, I'm writing 9 minus y equals 2. I'm going to solve that equation. 1/3 times 9 minus y equals 2. Well, 1/3 times 9 is 3. I can think of multiplying by a third. Multiplying by a third is the same thing as dividing by 3, right? Because if I kind of put that off to the side over here, 1/3 times 9, 9 is over that invisible 1, equals 9/3, which is of course just 3, okay? So if you forgot how to multiply fractions, it's over here. So 1/3 times 9 is 3 minus y equals 2. So I'm showing you this example for a couple reasons. One being there's a fraction, and secondly, we have this minus y, so there is another step. My goal is to get y alone. This is a positive 3, so I'm going to subtract 3 from both sides. That leaves me with negative y equals 2 minus 3 is negative 1. I want y alone. I do not want negative y. So I can remember, hopefully, that there's that imaginary 1 here. So if I want to get y alone, essentially, since this means negative 1 times y, to get y alone, I'm doing the opposite. The opposite of multiplication is division. So I'm dividing both sides by negative 1. Negative 1y divided by negative 1 is going to leave me with y. And negative 1 divided by negative 1 is 1, right? How many times does negative 1 go into 1? How many times does negative 1 go into negative 1? It goes in 1 time. Right? So now I can actually graph this point. I have my x, when my x is 9, my y is 1. So I'm going over 9, up 1. So I'm expecting that you are going to find 2 more points, graph them on the line, and then connect them with a line. Same thing on page 175. Definitely let me know if you have any questions.